Okay, we'll start the class. So in last class, we completed up to this slide, advantages and disadvantages of GIS. Okay, so I gave introduction about GIS and I told about GIS software. So what is meant by GIS? What are the uses of GIS? Okay, so these things and all we saw in the last class itself. Okay, so up to advantages and disadvantages we saw in the last class itself. Okay, so next we'll start the basics of GIS. Okay, so GIS is one of the most common product of a GIS is a map. Okay, the most common product of a GIS is a map. Okay, so the GIS map is of two views. Okay, the raster view. Okay, raster, the raster view of the world, and one more view is vector view of the world. Okay, so the raster view and vector view, and we are also having spatial objects. Okay, so spatial object is nothing but the spatial points only. Okay, so three-dimensional figure diagram and all comes under spatial objects only. Okay, so raster view will it is in the form of grid form. Okay, so vector it is in the points. Okay, so this image shows okay how the raster view and the vector view and all. Okay, so points of the hotels. Okay, so this is a spatial object. Okay, the points of the hotels is in the raster view will be like this, and in vector view it will be like this. Okay, suppose line nodes means in raster view it will be like this. Okay, the grid form it is a line node. Okay, and it is in the vector view. Similarly, in area of forest and all, in raster view, it will be like this. Okay, in grid form only, it will be like this. In vector view, it will be a polygon chain. Okay, polygon or chain. Number of chain or line. Okay, connected to form a polygon shape. Okay, so area of forest and all will be like this only. Then network. Okay, for example, roads. Okay, so spatial object is roads. So raster view, it will be like this, and in vector view, it is a number of points. Okay, connections of number of lines. Okay, line one, line two, line three, line four. Okay, so all these lines are going to be number of nodes. Okay, and the last one, the spatial object is mountain. Okay, surface elevation. So in raster view, it will be like this, and vector view, it will be like a contour mapping. Okay, so in the real world, okay, the maps, the points are only we are connecting. Okay, the points or coordinates are connected to the map. Okay, so this is a data model. Okay, the coordinates are connected in the marked in the data model or maps. So we have to know what is raster, what is vector, the difference between raster and vector. Okay, so already I mentioned the raster, they are composed of pixels. Okay, so the previous figure, it will be like a pixel. Okay, but vector it is composed of a path. Okay, in raster graphics, refresh process is independent of the complexity of the image. Okay, but in vector graphics, flicker when the number of primitives in the image become too large. Okay, so here the refreshing process can be done. Okay, for the complexity of the image, independently it will occur. But in vector graphics, flickering may occurs to enlarge the views of the map. In raster graphics, graphic primitives are specified in terms of endpoints and must be scanned converted into corresponding pixels. In vector graphics, scan conversion is not required. Okay, so in raster graphics, scan conversion is required. Okay, but here the vector graphics, scan conversion is not required. Okay, the raster graphics can draw mathematical curves, polygons, and boundaries of curved primitives only by pixel approximation. But in vector graphics draw continuous and smooth lines. Okay, continuous and smooth lines by using nodes only. This one only. Okay, continuous and smooth lines and all. Here they draw a raster. They are using by pixels. Okay, we can draw easily by using vector graphics. Raster graphics is costless, but vector graphics cost more as compared to raster. So raster graphics occupy more space, which depends on image quality. A vector graphics occupies less space. Okay, so raster graphics, the file extensions are BMP, TIF, .gif, JPG, and all. Here the vector graphics, the file extensions are SVG, EPS, PDF, AI, .dx, etc. Okay, so some of the basic geographical concepts. So spatial objects. Okay, spatial object is nothing but denoting the spaces only, space points only. Okay, so here what they are saying, delimited geographical areas. Okay, delimited geographical areas with a number of different kind of associated attributes. Okay, so the spatial object is a delimited geographical area. Okay, some of the points in the land and all are limited geographical area. Okay, but in space it is a delimited geographical area. Okay, the space only we are referring it as a delimited geographical area with a number of different kind of associated attributes. Attributes means additional points only. With the additional points, it may be clearly denoted what kind of point is that, what kind of place is that. Okay, like that. So spatial object, first one. Second one, point. Okay, so point, important point or important key. Okay, a spatial object with no area. So point, a spatial object with no area. A key attribute is its geodetic location. Many attributes can be associated with a point. Okay, so point is a key attribute of its geodetic location. Many attributes can be associated with a point. For example, you can see in the next slide. Okay, so this is a map consisted of cities. Okay, for example, cities name Medina, Riyadh, Jeddah. Okay, so they are mentioning these cities by using points. Okay, here they are mentioning Om. Okay, H the symbol they are using, maybe denoting, it denotes home or house. Okay, by using points only they are denoting this. And this is one more map denoting the will. Okay, so will, by using points only they are denoting this. Okay, so it is a key attribute, denotes the geodetic location. So many attributes also may be associated with that point. Okay, the next concept is line. So line, a spatial object made up of a connected sequence of points. Okay, so line is nothing but sequence of points. Lines have no width. Thus, a specific location will be on one side of a line or other, but never on a line. Okay, so it is a line. Okay, so for representing street, river, and all, we'll use a line. Next one, node. Special kind of points. Node is also a point only. Special kind of point showing start, in, and junction of line segments. Okay, so in line segments, okay, starting point, ending point. Okay, so this the node is a special point. Okay, next one, polygon. A closed area. We know what is polygon. A closed area. Simple polygons are undivided areas, while complex polygons are divided into areas of different characteristics. Okay, so more number of sides only we will name it as a polygon. Okay, so polygon means area will come here. Okay, so here also simple polygon, complex polygon and all comes. Okay, then chain, special kind of line segments which corresponds to a portion of the bounding edge of the polygon. Okay, so these are the some of the basic geographical concept. Okay, you have to know what is spatial object, what is point, what is line, nodes, polygon, chains, and all. Okay, it will comes under 2 marks. Okay, so points. Okay, so we use points to denote cities, homes or house, wells. Okay, and lines are used for denoting contour lines. Okay, streets, rivers. Okay, so for that purpose lines is using. Then area, so area is for denoting the countries, land, land space, land parcels. Okay, So point will be like this. This is a line, okay, and area. This is a raster view, okay. In nominal point used for denoting the town, mine, benchmark. Okay, so these are the symbols. Okay, for denoting town, a dot. Okay, for denoting mine and all, they are using axe symbol. For benchmark, they are using a BM. Okay, for denoting the road, okay, a line symbol will, okay, this kind of line symbol, a curved road, okay, straight road means they'll use this, okay, continuous dotted line. Then stream, for denoting stream, they'll use this kind of lines. For area, okay, for a swamp area, they will denote this, okay. It will consist of triangle, rectangle and all, okay. It denotes a swamp. For denoting desert area, they'll use this symbol, okay. No triangle symbols in this. And for denoting the forest area, they'll use this symbol, okay. Trees only. So this is a nominal symbols for denoting point, line, area. And this is ordinal symbol, okay. For point, large, medium, small, these kind of symbols they'll use, okay. And for line, interstate highway, they'll use this type of symbol, line symbol. And US highway, they'll use this state highway. And for country road, okay. Area, for business district, they'll use primary means they'll use this type of symbol. And for secondary and for major plume also, they'll use this kind of symbol for denoting this, okay. Minor plume means pollution only, okay. Plume denotes pollution, okay. Pollution from the chimneys and all. So minor means minimum level of pollutants. Major plume means major level of pollutants, okay. So which district have minor pollutants and which city has major level of pollutants, okay. They'll use this kind of symbols. Then interval ratio, okay. For point, they'll use this type of symbol, okay. Each dot represents 200 objects, okay. Then for contours, floor lines, and for population density, they'll use this, okay, like a bar diagram. Each box denotes a population count only. Do you have any doubt in this? Manisha? Manisha, are you there? Hello?
Hello, sir. I'm there, sir.
Hmm. Subject
I
puridama?
texted. Yes, sir. Yes.
Hmm. Okay. 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 So the next slide is denotes basic geographical concepts. The same scale only will come. Okay. Uh, so we are denoting the map only. No, the product of GIS is map only. No. So map is of some scale. Okay. So large scale or small scale. For small area means we'll use small scale. For large area we'll use large scale. Okay. And their resolution is also one more important point. If I use more pixel means it will the image will be clear. Less amount of pixel means the image will not be that much clear. Okay, you, the figure source. Okay, the same image only. The first two image is not clear. Okay, so the distance is of 1 meter. Here the second one is 50 centimeter. The third image is of 25 centimeter. Okay, the scale ratio maybe 25 centimeter, and the last one is of 10 centimeter. It will be more clear. Okay, here also the this image also is somewhat clear, but it cannot be that much clear in this area and all. Okay, but you see this image, it will be more clear, okay. So if you want a clear map means we want to know about the scale and the resolution also, okay. So what area, how much area the map covers, whether small area or large area. If the map is of small area means we'll use small scale. Larger area means we'll use large scale, and the resolution also one more important point. How much pixel it denotes. Okay. Uh, so next one is attributes. Attribute, general meaning of attribute is additional only. Okay, additional features which it has. Okay, like that only denotes attributes. So first point, pertinent information. Okay, so pertinent information of geospatial data. Okay, so pertinent means important information of geospatial data. Okay, example, if a line, okay, so using a line for denoting street or river. Okay, but attributes means if a line is representing a road through geographic data, okay, then it is helping information such as width. Okay, so what are the attributes means here for the road? We have to know the width of the road, condition of the road, name, okay, whether it is metal or unmetal, etc. So like these information and all, only we are naming as attributes. Okay, so for example, for a road it will come the width of the road, conditions of the road, name of the road, metalled or unmetalled. So okay, so these are the attributes. Okay, so only those attributes should be selected or acquired which might be required in the analysis. Okay, so for example, if you want to take the map for a river by using GIS means the final product will be map by, with consist of river only. Okay, so river we'll have attributes also. Okay, so where it is starts, width of the river, depth of the river. Okay, so these points and all comes under attributes for the river. So the next slide is just data model. Okay, so database management system, DBMS only. Okay, so this slide is about datas. Okay, the collection of datas for GIS for doing GIS work. So GIS stores information about the world as a collection of thematic layers that can be linked together by geography. Okay, so GIS stores information about the world as a collection of thematic layers. Okay, so number of information, number of data collected, and it stores. Okay, so after this, the thematic layers that can be linked together by geography. Okay, so the basic data type in a GIS reflects traditional data found on a map. Okay, so the basic data type of in a GIS reflects the traditional data found on a map. Okay, so after the final product of the map only, we are having traditional data in that map. Okay, so that is the basic data type. Then spatial data. Okay, so these 2 points, spatial data and attribute data, they'll ask in 2 marks what is spatial data, what is attribute data. So spatial data describes the absolute and relative location of the geographic features mainly in the space only. Okay, so attribute data is additional data. Okay, for example, road. So for denoting road you'll use line, for river also you'll use line, curved lines. Okay, so attribute data means you have to know the width of the road, the name of the road. Okay, the material used in that road. So like that, these and all the attribute data. For a river, the origin point of the river, then width of the river, depth of the river. Okay, so these are attribute for the rivers. So describe characteristics of the spatial features. These characteristics can be quantitative or qualitative in nature. Okay, so the attribute data may be quantitative or qualitative in nature. So attribute data is often referred to as a tabular data. Okay, so they are it is a tabular data. So physical reality. Okay, so they are collecting the data. Okay, physical reality, then real world model, data model, database, finally maps or reports. Okay, so actual phenomenon, entity, object. Okay, then database, that is also comes under object. Then final maps. Okay, in there they are using symbols, line or text. So spatial data models. Okay, so three basic types of spatial data models have evolved for storing geographic data digitally. So these are referred to as number one, Raster, number two, vector, number three, image. So image is a real world. Okay, so real view. So Raster view, so it is in the grid form. Okay, Raster and vector. Okay, this is a vector view. Okay, but in image or real world, it looks like a real view, real image. Okay, so image data utilizes techniques very similar to raster data, however typically lacks the internal formats required for analysis and modeling the data. Okay, so raster data models incorporate the use of grid cell data structure where the geographic area is divided into cells identified by row and column. So raster data we know. So raster data is incorporated by the use of grid cell only. Okay. So where the geographic area is divided into cells identified by the rows and columns. For digital representations of aerial photographs, satellite images, scanned paper maps, and other applications with very detailed images. Okay, so we'll use raster data models. Okay, for digital representation, we have to use aerial photographs. Okay, aerial photographs, satellite images, scanned paper. So all these data we can incorporate in this GIS. Okay, if we want in the raster data model means also we can get it. Okay, it will be in grid form. Okay, the aerial photographs will take the aerial photograph and we are incorporating or we are feeding in the software GIS. Okay, so in raster data output it will be in the grid form only. The aerial out photograph and satellite images and all will be in the grid form. That only they are mentioning. Okay, so a raster data structure is in fact of matrix. Okay, so number of grids, so it's a matrix. It's in a fact a matrix where any coordinate can be quickly calculated if the origin point is known and the size of the grid cell is known. Okay, so we can calculate the origin point or ending point and all easily by using raster data models. Okay, so next, vector data models. So vector storage implies the use of vectors. Okay, directional lines only. So vector data models uh, is consist of directional lines only. Okay, so the use of vectors to represent a geographic feature. A vector data is characterized by the use of sequential points or vertices to define a linear segment. Okay, so each vertex consists of an x coordinate and a y coordinate. Okay, so vector lines are often referred to as arcs and consist of string of vertices terminated by a node. Okay, so this is an example image. Okay, next, geometry and topology of vector data. The most popular method of retaining spatial relationships among features is to explicitly record adjacency information in what is known as the topologic data model. Okay, the topologic data structure is often referred to as an intelligent data structure. Okay, topology is nothing but map only. Okay, so geometric data. So geometry consists of point, line, area. Okay, point, line, area. It will further forms map. Okay, or area. So we'll use point, line. Okay, so point and node. Okay, line, by using two nodes we'll connect a line. Okay, a string. So number of lines, series of lines. Okay, series of lines connected by nodes. This is a string. Okay, and then area. If a closed one means if a string is a closed. Okay, by using string or line it is a closed path means it denotes area. Okay, so number of area polygons, number of sides means polygon. Okay, so it is a geometry and then this is a topology. Okay, clockwise chain. Then image data models. Okay, so image data is typically used in GIS system as a background display data if the image has been rectified or georeference or as geographic attribute. Okay, so image data can also be used. Okay, it is also a graphic attribute. Image data must be converted into a raster format. Okay, so that only we already saw that. Okay, in previous slide. Okay, so for aerial photographs, satellite images, scanned paper maps and other applications and other images. Okay, we can feed it into GIS and we can get as a raster data models. Okay, so same image data must be converted into a raster format to be used analytically with GIS. Okay, so we can feed the image also as a raw output. raw input. Okay. Then attribute data models. So attribute data refers to pertinent information, okay, important information attached to each geospatial data. Okay, a variety of different database models exist for the storage and management of attribute data. Okay, for attribute data itself, there is a database. Okay, for the storage and for the management of attribute data. The most common are tabular, hierarchical, okay, network, relational, object oriented. Okay, it's the attribute data should be in a tabular form, and it should be in a hierarchy. Okay, it should be in a hierarchical order, and it should follow it. It has a it is its own network and relational. Each data is a relational, object oriented. Okay, so we all know. So what is attribute data? Okay, so what is the common form? A common form of attribute data is a tabular, hierarchical, network, relation, object oriented. Okay, that only they mentioned here. So hierarchical database organizes data in a tree structure. Okay, data is structured downward in a hierarchy of tables. Okay, it is a data are in a hierarchical order. The network database organizes the data in a network or plex structure. Each data are connected. Okay, network. Any column in a plex structure can be linked to any other. Object oriented database models manages data through objects. Okay, so what is your objective? Okay, so those data only we'll have those data separately. So object oriented data, so an object is a collection of data elements and operations that together are considered a single entity. Okay, so the object oriented database is a relatively new model. This approach has the attraction that query is very natural, as features can be bundled together with attributes at the database administrator discretion. Okay, so next note, a separate data model is used to store and maintain attribute data for just server. Okay, a separate data model also can be created and we can store information in that. Okay, so these data models may exist internally within the GIS software or may be reflected in the external commercial database management software. Okay, so data models only we so far use. There are three types of image data models, attribute data models, and finally separate data models. Okay, we are saving and storing that information. Okay, so generally there are two data models only: image data models, attribute data models only. Okay, these are also comes. Okay, spatial. Okay, so just data model, in just data model, spatial data and attribute data will comes. Okay, so in spatial data, raster data, vector and image will come. Okay, so raster data models, vector data models and image. Okay, third one is image. In attribute data models, in attribute there are different forms. Attribute data are in different forms. Okay, in tabular or hierarchical, network, relational, object oriented. Okay, okay, do you have any doubt in this so far? Mohammed Priya, Mohammed Priya, are you there? Ashwin,
Sir,
என்ன கண்ணா டெக்ஸ்ட் பண்றீங்களா, மெசேஜ் பண்ணிடுறீங்களா?
ஆமாம் சார்.
ம், ஓகே. இதுக்கு கொஞ்சம் போர் அடிக்கிற மாதிரி தான் இருக்கும். ஏன்னா நியூ சப்ஜெக்ட், நியூ கான்செப்ட் அப்படிங்கிறதுனால கொஞ்சம் இதாக போரிங்காக தான் இருக்கும். ஓகே, ஆனால் கொஞ்சம் இன்ட்ரெஸ்ட் காமிச்சிங்க அப்படின்னா ஓகே. இந்த சப்ஜெக்ட், இந்த ஃபீல்டில் வந்துட்டு நிறைய ஜாப் ஆப்பர்ச்சுனிட்டிஸ்ல இருக்கு. நீ ஜிஸ்ஸை வந்துட்டு தனியாக லேர்ன் பண்ணி அந்த சாஃப்ட்வேரும் நல்லா லேர்ன் பண்ணிக்கிட்ட அப்படின்னா ஜாப் ஆப்பர்ச்சுனிட்டிஸ் எல்லாமே இருக்கு. ஓகே, உனக்கு சப்போஸ் இந்த சப்ஜெக்ட்ல இன்ட்ரெஸ்ட் வந்து தனியாக சாஃப்ட்வேர்ல லேர்ன் பண்ண அப்படிங்கும்போது ஜாப் ஆப்பர்ச்சுனிட்டிஸ் ஈஸியாகவே கிடைக்கும். அதனால முடிஞ்ச அளவுக்கு இன்ட்ரெஸ்ட் காட்டுங்க. ஓகே,
ஓகே சார்.
okay, I'll stop here. Okay, we'll see you in the next class.
தேங்க்யூ சார்.
Okay, thank you.
Okay, sir. Thank you, sir.